This video is brought to you by TS4U IT Engineering Bootcamp.
Now I have the quick. I would like to you just give me a design, your approach, or if you have designed before, just design an environment on AWS that can handle and tolerate high volume of traffic for a website that has some static contents like bunch of images and Node.js backend.
Okay, can you please repeat the question again? Like the images means?
Yes, so like the pictures on the application. So static, the content,
Static.
the text and the images, and the backend is Node.js application. I think you have mentioned in the previous the answer, but I would like you to highlight the high volume of traffic this design should be able to handle.
Yes. So yeah, since you've mentioned I will have a front end, I will have a back end, right? So may I know like which technology that the front end will be using?
So we are using the purely the HTML, CSS, and the JavaScript and the React framework.
Okay, cool. So since we're using this, and I have worked previously with this kind of technologies as well. So yeah, what I will do is for the front end, we can use S3, the S3 static website hosting feature to store all of the front end contents. Okay. So whatever the front end builds are the static files with JavaScript, HTML, and CSS. And basically, whenever we build a React project, it will give us the static file output as the build artifact, right? So what we can do, we can just store all of the files within a S3. We can enable the S3 static website hosting, and then in front of that, we can enable the CloudFront as a CDN. Okay, so CloudFront by default is a very scalable system. It can handle millions of requests per minute. So what we can do, we can just enable CloudFront with the S3 static website hosting as the CloudFront origin. And then with the CloudFront, we can actually set up our custom domain name so that our users can actually like redirect to our CloudFront to get the front end. Okay. And from the CloudFront configuration, we can create some more origins to connect to our backend, right? So in order to connect from the CloudFront to our backend, we basically need to have our backend somewhere. So since you've mentioned the high traffic volume, so now we need to actually create a highly available system with automated scaling capabilities as well, because we need to scale as the user grows. Okay, so what I can do in this case is basically, as we are using in our system, we are using Kubernetes, the EKS cluster as our backend like deployment or a backend infrastructure. So we basically have multiple options. We have the AWS Autoscaler enabled into our Kubernetes cluster, so that whenever we try to create a pod in Kubernetes, it will see that, okay, if I have the capacity to do that, if I don't have enough nodes to create it, AWS will automatically create nodes for us. Okay, so we have the maximum capacity set to a specific number that, okay, this is how much our Kubernetes cluster can scale. Okay, so from the outside, we have the AWS Autoscaler, and then from the inside, we can actually deploy all of our Node.js backends. If it is a microservice, then we can deploy multiple deployments. If it's just a monolith, we can just deploy one single service. So we can deploy it and then enable the HPA, the Horizontal Pod Autoscaler, based on the CPU request. Okay, so whenever the pod will handle a certain number of users, it will basically see that, okay, the average CPU usage is, let's say, 70%. Then we'll set up the configuration in such a way so that it actually scales up the pod's number. So whenever the pod will be scaling based on the request, if the pods can see that, okay, I have resource constraints, I cannot launch to this node because I don't have enough space, AWS Autoscaler will see that because there are node constraints, right? So since we have that set up as well, it will automatically launch a new node and let the pod like spawn on that new node. So it may take 1 or 2 minutes, so that we'll have that capacity to scale more and more. So since our Kubernetes cluster will be running inside, we need to handle the pressure from the outside that are coming inside our Kubernetes cluster. So in this case, we can use a Kubernetes Ingress to launch an AWS ALB or NLB. If we have a very high volume of load, we can launch AWS NLB, which is the network load balancer that has the capacity to like handle millions and millions of requests per second. So what we can do is we can enable the AWS network load balancer to as an ingress, so that all of our requests that are coming from the CloudFront, because CloudFront will be requesting to the backend, right? So all of the requests will be coming from the CloudFront through our load balancer. It can be a network load balancer or application load balancer based on our needs, what we need to do with the load balancer, and then that load balancer will be routing all the requests inside our cluster. And since the cluster actually is automatically scaled, we can have set up like this, so that we can handle like millions of traffics in every single minute or hour.
Thank you.